Hello scholars, welcome. Mr. Hinkle here to tell you about a very special type of sedimentary rock that we call biochemical sedimentary rock. So let's get into it. We're going to discuss, well, first I want to discuss how they form, where they come from, and then I've got some examples to show you. So there are organisms in the ocean that float and use the power of the sun to reproduce. They're called marine phytoplankton. And marine phytoplankton take up minerals from the ocean, calcium carbonate and silica, to create extravagant, unique shapes and appendages so that they can float utilizing the sun's solar energy. Well, in certain periods, the primary productivity will explode and the accumulation will deposit at the bottom of the ocean, forming a siliceous ooze or a calcareous ooze that then later turns into sedimentary rock. So I know I glazed over a few properties there, but just bear with me. Marine phytoplankton deposit at the bottom of the ocean, and this is the basis for forming biochemical sedimentary rock. Now, the types of rock that they form are going to be made of primarily the mineral calcite, giving us limestone, or dolomite when the calcite is chemically altered in this environment of lithification to form dolostone. And we could see it up here. I'll go back one. The Dolomites in Italy are rocks that formed in a sedimentary basin and through the processes of plate tectonics traveled across the surface of the earth, were unburied or exhumed, uplifted, and then now create the majestic Dolomite Mountains. Geology is utterly amazing. How our earth came to be the way that it is never stops just knocking my socks off. I absolutely love it. Dolomites made of marine phytoplankton millions of years ago. Let's keep going. So we've got limestone, dolostone, fossiliferous limestone. So this is limestone that also incorporates fossils. So you can see the imprints of shells. A fossil is the remains of a once living organism. And there's kind of a cool property that goes on here because the rock is made primarily of calcite from the calcium carbonate shells of the marine organisms. This is diluted hydrochloric acid, which reacts to calcite. So when we see here, we put this on the rock, it starts to fizz and it starts to bubble. Very cool. What's happening is the reaction of the calcium carbonate that makes up the rock, that makes up the limestone with the hydrochloric acid. So this is a test. Is this a limestone made of calcite? Reacts with HCl? Yes, it is. So fossiliferous limestone would be one of our biochemical sedimentary rocks. The bio comes from the fact that it's made from the remains of once living organisms. The chemical is because it chemically precipitates into the rock type of limestone as opposed to clastic sedimentary rocks that are from the physical weathering and the transportation of broken pieces of rock known as clasts or detritus. Okay, cool. Let's keep going. Coquina is shells that have not been fossilized, but they have been lithified together to form a predominantly loosely cemented shell and shell fragmented rock. Different than our fossiliferous limestone, which are shell fossils that have lithified into limestone. This is kind of like gluing a bunch of cement or gluing a bunch of shells together to form coquina. the White Cliffs of Dover. This is a very famous, popular outcrop of the United Kingdom. Here's a big lighthouse. This cliff face is hundreds of feet tall. And this comes from a very specific marine phytoplanktonic species known as coccolithophores. When you have the deposition of coccolithophores at the bottom of the ocean, they then form a very unique type of biochemical sedimentary rock known as chalk. Chalk, like if I had a chalkboard, I could be writing on the chalkboard, because everything on this earth, everything that we have comes from this earth. Everything that we have produced, manufactured, created, that we utilize on our planet comes from our planet, and they are all earth materials. That's a pretty cool thing. Okay, micrite is when you have a calcite mud, super fine-grained, very, very fine-grained limestone. It's a very challenging rock to identify, but it has microfossils in it that can only be seen using a microscope. So optical mineralogy and optical petrology is a very useful counterpart when identifying rocks and minerals to see the unique properties of how rocks and minerals display under the thin scope microscope. What else do we got? Identifying and classifying. So biochemical is part of the biochemical, chemical, and organic kind of cluster, which are a little bit different than the clastic sedimentary rocks. And we're looking at these by identifying the composition that make up the sedimentary rock, and then the description. So textural descriptions, reactional descriptions. Really, we're looking at composition and description to identify biochemical, chemical, and organic also, but in the case of this lecture, biochemical sedimentary rocks. So these are awesome rocks that are created from geological processes that highlight the dynamic planet that we live on. Thank you so much, and I'll see you again.